back to, ladies and gentlemen, let's take a look at your textbook page 29, number 7 that I've asked you to work on. So the kids in class, you can take this down if you want, or you can just sit and watch, which I think might be wise. The kids at home, you can sort of take this down if you want, or you can just sort of watch and go back and try it again. What we have here is we have a construction worker, and he's working on a high-rise building, and he's 320 meters off the ground. So down to the ground. And he's going to drop a bolt, which is never a good idea, but he's going to drop a bolt. And that bolt is going to fall, and notice what they give you. They're giving you the bolt is at a height of S meters. They're giving you a height of S meters at 320 minus 5t squared, anywhere between t equals 0 and t equals 8. I'll bring that up a little bit. So they're telling you that this is height. Okay, so that is a height formula, which kind of makes sense, because if you think about height right at t equals 0, right here, its height is going to be 320 minus 50 squared, so it's 320. Its height is 320 meters off the ground when time equals 0. Okay? So, and then what the question goes ahead and asks you to do is to calculate, and this threw everyone off. It asked you for average velocity during the first second. Now there's a couple of things that threw everyone off there. The first one is that it was average velocity, because I had just finished a whole bunch of questions doing instantaneous velocity, and all of a sudden I asked you average velocity. And I did that on purpose. And the other thing that threw you off there is this concept of during the first second. This is during the first second. The first second starts at t equals 0, and the first second stops at t equals 1. That's during the first second. And my distance, my height at the first moment in time is s of 0. And my height at the end of the first second is s of 1. Take that back to calculating the average velocity. The average velocity, it'd be nice if I could spell, is delta d over delta t. Now some of you might not know that. You might not know that velocity and speed is distance divided by time. I want you to think of driving. Think about driving on the link and you're going 90 kilometers per hour. Well, if you think about that, I've got to find somewhere to write this, 90 kilometers per hour is a distance divided by time. So even if you haven't taken any physics at all, we all should know that speed is distance divided by time, and velocity is just a speed with a direction associated with it. So these are things that we should become familiar with. So this is going to be a change in distance over a change in time. And in our case, we could also think about it as d2 over, subtract d1 over t2 subtract t1. And in our case, we don't have a d formula, we have an s formula. That's just what they chose to call it. It's not a big deal. It's s's. So in our case, it's going to be s of 2, which in this case is s of 1. That's our second height. Subtract our first height all over our second time. Subtract our first time. And that probably threw you off. Okay? A couple of things why it threw you off. First of all, there's no limit, because I'm not after instantaneous, so you shouldn't have a limit in here at all. I'm after average velocity. And the thing that probably threw you off is the fact that we're talking about during the first second. So what this would become then is if I take 1 and plug it in for t, I'm going to get 320 minus 5 for the first one. And if I take 0 and plug it in for t, I'm going to get 320 over top of 1. That's going to be 315 minus 320 over top of 1, and I think that works out to -5 meters per second. And depending if you're looking at the back of the book or if you're looking at the online answers, you might have the negative associated with it or not. I can handle both as long as we say it's 5 meters per second towards the ground, or I can handle -5 meters per second in relationship to up being positive. But either way, we're looking for this 5 meters per second. Now the next part is asking for the average velocity during the third second. So again, the idea of average velocity is going to be the d2 minus the d1 over t2 minus t1, change in distance over change in time. Only this time, the third second, if this is your first second, this is your second second, your third second starts at t equals 2 and ends at t equals 3. And so your ending height is going to be s of 3, and your starting height is s of 2. So when we do d2 minus d1, it's going to be s of 3 minus s of 2 over top of 3 minus 2. And I'll leave the rest for you to calculate because it calculates out the exact same way. Remembering that your height formula is 320 minus 5t squared. That's what needs to be used in here. All right, so now we get to B part. B part wanted the average velocity on the interval between 3 and 8. Well, that's okay, as again, average velocity is going to be delta d over delta t, and in this case, our ending height is s of 8, our starting height is s of 3, and the difference in our times is 8 minus 3. So that's a larger distance. Our delta t is different now. We have a larger interval there. And lastly, this question asks you for the velocity at t equals 2. Now remember, when we say just velocity in this course, from now on, we're actually saying instantaneous. Okay? So if I want average, I'll tell you average. But if I want instantaneous, I'll just say velocity. And so instantaneous velocity is given by the limit as delta. What do we want to use here? Delta x. I forget what I was using at this point in the lessons. It might have been t. Delta x approaches 0 of f of x delta x minus f of x over delta x. And again, I'm not sure where I was in the formula. We could also look at it this way. Oh, it's probably delta t. Ha ha. So this is going to confuse everyone. Ignore that. I've taught a lot more since I've done this. So this is going to be s of 2 plus delta t minus s of 2 over top of delta t. And remember, this is Newton, right? So this is Newton saying, okay, I've got my bolt falling, and my bolt's going to fall a certain distance after 2 seconds, and then I'm going to let it fall a little bit longer so that it falls 2 seconds plus a little bit more time. And so this is my second distance, my delta d. So this is the limit as t approaches 0 of delta d over delta t. And so what we come up with is the limit as delta t approaches 0 of, what was the formula? 320 minus 5, 2 plus delta t squared minus 320 minus 5, 2 squared. And then we just follow that through and solve it. We good? Okay, my My in-class group says we're good. I hope that helps out. Remember, there's a big difference between average rate of change, instantaneous rate of change, and that's how we solve that question.